What if I told you that two power supplies with the same efficiency and the same power factor can behave completely differently? One can be smooth, quiet, and stable, and the other bursting, spiking, and sometimes whining. And traditional PSU metrics, they won't show you any of that. This is why I created the Burst Activity Index, BAI. BAI is not another efficiency number. It's not another average. BAI measures behavior. Specifically, how a PSU behaves at idle and light loads. Because here is the reality. Modern systems don't run at full load most of the time. They sit at very low power or light loads, browsing, YouTube, office work, even gaming menus sometimes. That's where systems spend most of their life. And exactly there, PSUs enter burst mode. At low and light loads, the PSU doesn't operate continuously. It switches on, pushes energy, then switches off, waits, and repeats. This creates power spikes, idle gaps, unstable power factor, and sometimes coil whine. But standard measurements, they average everything out. Efficiency, average. Power factor, average. So you completely lose the real behavior. BAI focuses on three things. First, how aggressive the power bursts are. Second, how much time the PSU stays idle, even under light loads. And third, how unstable the power factor becomes. Together, these describe real PSU behavior in everyday usage. We measure average input power and peak input power, then peak to average ratio. If the PSU is smooth, this stays near 1. If it bursts aggressively, this increases. Next, idle fraction. How much time the PSU is effectively doing nothing, even at light loads. This can be significant. Then, power factor instability. We compare instant PF with window average PF. If they drift, the APFC converter is unstable. Now, combine everything. BAI raw, peak average -1 times idle fraction. Then include PF instability. BAI with PF, that's the equation. And finally, we scale it to a 0 to 100 score. And what the score means, 0 to 10 is excellent, smooth operation even at light loads. 10 to 30 is good, mild best behavior. 30 to 50 is noticeable, clearly burst driven operation. And 50 plus is poor, aggressive burst mode, unstable behavior. Higher score means worse behavior. This is the key. BAI is not about edge cases. It measures performance, where your system actually lives, idle, desktop, light load usage, not full load. And that's a huge shift. Now, here's where it gets interesting. Best behavior creates rapid power transitions. This stress transformers, inductors, and that produces coil whine. BAI doesn't measure sound, it measures the cause behind it. That's why high BAI means higher coil whine risk. I measure BAI at very low and light loads, typically around 2% load, where best behavior is strongest, using a long integration window, 15, 30 to 60 seconds. Continuous sampling, no shortcuts, no averaging tricks, full behavioral capture. Efficiency tells you losses. Ripple tells you electrical quality. Noise tells you acoustics. But BAI tells you something new. How the PSU behaves when your system is actually being used. And that's missing from every existing certification. This is where things are going now. BAI won't replace any existing metrics, but it will add a new dimension, behavior quality. Because a great PSU is not just efficient, it is stable, predictable, refined across all loads. especially the ones that matter the most. So, this is the best activity index, a new way to evaluate power supplies, not just by numbers, but by behavior, because in model systems, behavior is everything. Let me know what you think about that.